Solving linear equations by multiplying. Let's remember what a linear equation looks like. Ax plus b equals c. X was our variable. A, b, and c were real numbers. I'm going to write this with a symbol, meaning are elements of the real numbers, which I'm going to write as a bold R. One other thing we have to be concerned about here is A. Certainly A cannot equal 0, because if it did, well, we just have B is equal to C, right? Okay, previously, let's recall, we could solve something like x minus 5 equals 2, right? A is 1 in this case, by simply adding the same number to both sides. We did this last time. So in this case, I'll add 5 to both sides to isolate x, in other words, keeping the x on the left-hand side, but minus 5 and plus 5 add up to 0, so I'm left with x on the left-hand side, plus 2 and plus 5 is a plus 7. So that tells me if x is equal to 7, then it solves this equation x minus 5 equals 2, or I can write it that my solution set, in set notation, my solution is 7, and it's in a set, which is given by these curly brackets. Let's try another one just to get our memory working. Minus x plus 3 equals 0. In this case, if I subtracted 3 from both sides, I'd be kind of in a mess. I'll show you what that looks like. I wouldn't write this down, but I'll end up on this left-hand side with a negative x, and on the right-hand side, 0 plus a minus 3 gives me minus 3. But I'm not solving for negative x, I'm solving for positive x. So let's try a different way of it. Alright, let's not do that. Let's look at this problem again. Minus x plus 3 equals 0. What could I add to get x by itself? I'd have to add it to both sides. Yeah, why not a plus x to both sides? Let's see what that looks like. So these minus x plus x, well, this will just add up to 0, so I'm left with 3 now on the left-hand side. And on the right-hand side, I'm left with 0 plus x, or just x. So the value for x that would solve that equation, clearly, is 3. That makes sense. Good. Now let's see what happens if A, remember A in ax plus b equals c. Now let A not be equal to plus 1 or minus 1. Let's let A be something else. Well, let's also, it still can't be 0, right? So let's look at something like 1/2 x equals 3. There's no other term on the left-hand side with x or a number or anything. There's just one term on the left-hand side, one term on the right-hand side. And what I'm going to do is multiply the left-hand side by the same number as the right-hand side. And that number is going to be the reciprocal. I'm going to multiply by the reciprocal, that is 2 over 1, of the coefficient in front of x. But I have to do it to both sides. 2 over 1. When I multiply that, what do I get? Right here, I would get 2 over 2. but that's just 1, right? 2 over 2x. And over here I would get 3 times 2 is 6. Remember this 3 dot 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 is over 1. So I get 6 over 1. But this is the same as 1x, 1 times x, and that's just 6. And normally we don't write the 1, we just write x is equal to 6. So my solution set in this case is the number 6. Let's try something slightly different. We'll add a little bit to it. Let's try the example 3x minus 4 equals 9. Now notice I have two terms on the left-hand side. The first term has an x. The second term does not. And over on the right, no x there. So what I'd like to do on this equal sign, I'd like all the x's, all x terms on this side, and all numbers over here on the right. So my only term that has an x in it is 3x, so I'm going to leave it there. Just going to copy down the problem again, and I'm going to move this 4 out of the left-hand side. I'm going to move it out of the left-hand side by adding 4 to both sides. This is what we call isolating the x. So minus 4 and plus 4 adds to 0, and I'm left with 3x on the left, and 9 plus 4 is 13. So I used the addition to both sides, but I'm not left with 3. I'm not left with 1x, I'm left with 3x. So I'm going to multiply by the reciprocal of 3. What's the reciprocal of 3? That's right, 1/3. But recall, multiplying by 1/3 is the same as dividing by 3. You can try that out. So I'm going to take this 3x and I'm going to divide by 3 on one side, and I'm going to divide by 3 on the other. Interesting. This is a nice little fact over here. Something you should know. Alright, so 3 divided by 3 gives me 1. So I'm left with 1x on the left-hand side. And 13 divided by 3, I would just leave it as an improper fraction. You could say it was 4 1/3, but 13 over 3 is fine. Normally I don't keep the 1 in there. I would just simply say x is equal to 13 over 3, and I would say that is my solution. If I wanted it in set notation, I'll say or. I could say that the solution set to this equation is 13 over 3. Let's do one more. I'll use a different variable, z. My z's have a line through them, so you can tell them apart from a 2. 6z minus 4 is equal to z plus 11. Now remember, I wanted to get my variables on the left-hand side and all the numbers on the right-hand side. Because I have two terms on the left and two terms on the right, I can add and subtract terms to do that. So let's start by adding 4 to both sides. And I'm going to put it underneath its like term. Right, so I can just look straight up and down and say, oh, these 4's cancel or add up to 0. So 6z is now equal to z. 11 plus 4 is 15. Now I look at this equation and I think, oh, I've got a z on the right hand side. I don't want it there, so I'm going to remove it by subtracting it. But if I subtract on one side, I have to subtract on the other. Alright, so we'll add these two. 6z minus a z. 6 minus 1 gives me 5z. And now the z's on the right hand side cancel or add up to 0. And that's 15. Now I'm going to divide both sides by 5. Notice how I'm working vertically. Divide both sides by 5. This 5 and this 5 cancel. I say cancel, but really it's 5 over 5 times z. But 5 over 5 is just 1. So it's 1z is equal to 15 divided by 5 is 3, or z in this case equals 3. So the z that solves this equation, that value, is the same z value that solves that equation, the one we started with. Or we should say that the solution set is the number 3. To check this, I would put a 3 into this equation. 6z minus 4 equals z plus 11. So let's check it. So I'm going to say 6 times 3 minus 4. The question is, does that equal 3 plus 11? Well, order of operations says I multiply first, so I get 18 minus 4. Not sure. Does that equal, this is a question mark, does that equal 13 plus 11, which is 14? And I think you can see that, yes, 14 is equal to 14, so this checks. This is my solution. These are equivalent, or what are called equivalent equations. This one and this one. The same value, 3, solves both of these. And let's remember that solving an equation means finding the value, finding the set of numbers, in this case there's only one, finding the set that makes the statement true. Great. Good job.